Okay. Your bell work is under the TV. If you brought your phone, you can scan your QR code. You might want to, if you have one, get in a habit of bringing it with you. If you have any questions, don't go get it. It's fine. I'm just saying it might be a good thing to start the habit since that is something we're going to be utilizing in this class. Okay? Did anybody tell you Miss Cordy got it? Okay. She went and locked up. But I want to use your money. Let's have it. Good? Okay, if you would please get your homework out and lay it on the side of your desk. I'm going to come around and check to see if you got it. Can I use her? Yeah, you can use anything. Your book, your notes. I don't. If she wants to look at those two calculators.
It'll help As it is for homework, right?
Yeah, because he told us before. Well, it's basically for everyone.
Okay.
Cindy, do you have your homework? Yeah, so you add on this number 4. Okay. All right, when I say label 1, 2, and 3, I meant what you answered in question 1, 2, and 3, label those parts of your graph. If you put numbers beside them, that's fine, but I didn't mean that, so I need to clarify that. Did I see your... Oh,
You label it in here.
oh, sorry.
It's okay. Okay. Label each section in 1, 2, and 3. This will help you. This is the circle. Look for the circle.
Does that mean surgery? Or does that mean just there's 2 numbers in each section. So like what I said, label the graph, label up here, these sections, and then each part. Is this label? How about you use, okay. Look here, answer your question, answers to your questions. These are not using rational.
Huh? It says it's making a diagram of your whole numbers.
This side. Yeah.
What?
So this one says,
What determines the rational number? It's not irrational. Understand your codes, I'll tell you someplace you can go. Yeah.
how do you determine what a rational is? We talked about rational, irrational. Is every different number rational? Did you have any examples Monday of something that wasn't rational? And if you, and also the hand book?
Well, I thought I did.
That shows all of them here, but what makes them rational?
God is the repetition.
You did? Maybe each section.
Hey guys, it's a little different from the one in the book. The one in the book uses whole numbers. If that's confusing you, if you look at the study guide example, it's using the same examples I am. Whole numbers, integers, and rational numbers. Okay? So those are your three choices. You just need to decide where they're going to go, label them, put in examples, and then number 6 says, tell me so is that or is that not? If the number repeats forever or not? Okay. So you have this one goes on forever. It repeats. It's rational. Okay. This one does not repeat at all. It's rational. So what about this one? This one goes on forever. I don't understand exactly what you said, so you need to clarify this a little. Are you done? Yeah. When you're done, you can put it in the box. And then, yes. Does this one?
Determine the rational
This
number.
back. Look in the book.
I can't see anybody speaks to you want
How do you go through it?
Basically, the definition of a rational number. That will give you the easy.
That was rational. Now, here's the light. Yeah.
Change direction.
Okay, finish up please and turn it in. Let's talk about the homework. Now on the homework, you were supposed to determine if it was rational, whole number, natural. So I've got a little demonstration here.
Wait, Miss Howard, all
Yep.
whole numbers are natural, right? Is a whole, can a whole number be?
All
negative?
positive numbers. Okay,
Except for
I've got
Okay.
a thing that might help clarify, all right? Because sometimes when we look at something flat like that, it's a little hard to visualize. But what these kind of represent are little baskets that just hold the numbers, all right? So, like, the middle one is your natural numbers. And it fits inside of the whole numbers. So therefore, if it's part of that, then this one contains everything that's in it, which includes these. Does that make sense? So if you're looking at natural numbers, think about what you naturally count with. 1, 2, 3, yes. It's just what you naturally count. Then the next level just adds 0. That's the whole numbers. So this is 0 on with positive numbers. Integers includes negatives. So now we've got positive numbers, 0, and negatives. Then it goes into rational numbers, which is anything that can be shown as a fraction. So the thing is, when you have a number that goes 0.86753, it goes on forever, does not repeat, it is not rational. You guys are too young for like Star Wars. That is not rational. I don't think he said something similar to that. Spock did. But rational means it kind of like makes sense. If it's irrational, it doesn't make sense. If it goes on without repeating, it doesn't make sense. It's irrational. So that's kind of how I figured that out. Kind of distinguish between the two. So, yes, if something is in one group, it can be in the other groups. It's kind of like, this is 5th period, 6th period. This is my 6th period for algebra. This is the 8th graders. This is Alexander. Not all 8th grade, not every student at Alexander is in 8th grade. So we've got some others here. Not all 8th graders are in my 6th grade class, so there's others here. So they can be part of a bigger group, but they're still in their own group. So you guys are a group, you are my 6th period. Okay, this would be you, but you're still part of 8th grade. So you would be in another group as well. Yeah.
Is this sort of like when we were little and we did the division and we took all the little circles and put them into one big circle and then had like multiple of those big circles for the little circles?
It is just a way to categorize numbers, okay? We're just trying to give numbers categories. Like, we can say there's dogs, and then there is Cocker Spaniels, which is a type of dog. So, a natural number would be a type of integer, okay? So it's just a way to categorize numbers, that's all we're doing. So on your homework, you were to categorize the numbers. So let's look at our homework. Who needed a copy of the homework? So you did 1 through 7, and how would you write 13 as a fraction? Jordan? Over 100? Okay. Oh, that's right, you just decided whether it was rational or irrational. Okay, if a rational number can be written as a fraction, do you think you could? Any whole number, you just put it over 1. So what would it be? It would be a fraction then. So if it is, but we already know that if we can count with it, it's in that group. So what did you get with number 1? Here you go, sorry.
Rational, integer, number.
Very good. Okay, it fits all 3 categories. 57. Malik. Number 3. You're confused. Okay, all we're wanting to know on your homework. Yeah, the front you did in class. Number 3, 57. Rational.
Rational.
Integer.
Whole number.
Okay. And natural. It is all 3. Okay, because whenever you just have one of those numbers you count with, one of those natural numbers, if you can pop it over 1 real easy and make it into a fraction so it fits in 1. Here's a way to think of it, okay? Like I said, I've got my 6th period, 8th graders at Alexander. So you are in it. You're in every single group. So if you see a number that you naturally count with, you automatically know it's going to be in every group. Right there. It's going to be a whole number, it's going to be an integer, and it's going to be a rational number. Number 5, -3 and 4/5. Math.
Rational and integer.
It is an integer and it is rational because it can be written as a fraction, and it is wait. An integer. How did you get that? It is negative. Okay. These are integers. They're like animals. Okay. Let's look at what 3 and 4/5 would be as a fraction. Okay. Do you guys know how to do that? We got 3 and 4/5. Okay. This is our denominator, so it's going to stay our denominator. We times 5 and 3 and get 15. Yes, but where would you go with that? What would your answer be? And then what would you do with 4? So what would you do? Okay. That is the right thought process, but this whole number is negative. So that means this is the same thing as like a -4 too. Yes, yeah. So my recommendation is to put the negative on when you're done. Okay, just do the math first. So it would be 15 plus 4 is 19, and it's a negative. All right. Can this be reduced? Simplified in any way? Good night. No. Okay. So do we agree this is a fraction? Yes. Yes. So check. It is a rational number. Do you see any numbers like this up here, Matt? Any fractions up there? Those are our integers. No. Okay. So, huh?
So it's just rational.
So let's see. What about -1. Maria. It's number 7. Yeah, rational, okay. And what's the I stand for, do you know? Integer, yeah. It's a negative number, so it's an integer, and then it can be made into a fraction, so it is rational. So let's move on down to the bottom. 16 through 32. 27. Hunter. Right, he said it's rational, integer, and whole. It fits in all three. 28. What? Oh, and natural. I'm sorry. That was an add-on. Yeah, natural too, because it is something we can't with. And 28. Michaela.
Wouldn't it be an integer and a rational number?
For 28?
Yeah.
Okay. An integer is a negative, but an integer doesn't have a decimal point or a fraction. It's just a number. So it's a number with either positive or negative. It's one of these. Okay? So negative 2.54. That would be something you could switch into a fraction. Could 0.54 be put into a fraction? When I say that, I say it's -2 and 54